Hello, in this presentation we're going to measure the speed of a wave. The speed of a wave measures how far one particular crest or trough moves in a given amount of time. Let's look at the experiment in figure 1. These are waves moving in a ripple tank. This figure shows a top view for waves in a ripple tank. If we have a side view for the ripple tank, we can easily demonstrate the waveform, which is a sine wave. The maximum amplitude reached in these waves are called the crests, and the minimum amplitudes demonstrate the troughs of the wave. If we can link the side view of the ripple tank with its top view as shown in this figure, we can notice that the darker regions, which contain more water, demonstrate the crests. However, the lighter region, which has lower water, demonstrates the trough regions of the waves. So in this figure, the black lines demonstrate the crests of the waves. And recall that the distance between two successive crests is the wavelength of this wave, and the wavelength is symbolized by the Greek letter lambda. This question asks what happens to the wavelength when you increase the frequency. So let's increase the frequency and notice what happens. Here, there's a slider where we can increase the frequency of waves by dragging up on the control bar. So let's increase the frequency. Have you noticed what happened to the wavelength? Well, the distance between the dark lines, which represents wavelength, decreases. So the wavelength decreases as the frequency increases. Let's return back to the wave equation. The wave equation states that the speed is equal to the frequency multiplied by the wavelength. If we rearrange this formula to obtain the frequency in terms of the wavelength, it rearranges to the frequency is equal to the speed divided by the wavelength. This means that the frequency and the wavelength are inversely proportional to each other by a constant factor, which is the speed of the wave. So the wavelength decreases as the frequency increases, and by decreasing the frequency, the wavelength increases. So the answer for this question is that the wavelength decreases. Let's check it. Correct one. This inversely proportional relation applies for both if the frequency increases, the wavelength decreases, and vice versa. So now if we reduce the frequency, what do you think will happen to the wavelength? Yes, the wavelength increases. By decreasing the frequency, the wavelength increases. That's correct. So what happens to the speed of the waves as you change the frequency? As we noticed, when the frequency changes, the wavelength changes accordingly. However, the speed stays the same. Let's check it. So, the speed is independent of the frequency of the wave. That's correct.